Hey, Group 2. So you are tasked with the following problem, or at least it's a similar problem. You won't have the same numbers, but your picture should look exactly the same. And you are tasked to find um, what F1 is and what F2 is. So that's what we're going to be looking for. We're going to be looking to find specifically what F1 and F2 is. And the trick, as was mentioned in class, for all of these problems is not only does it have to balance, so the torque around support A and the torque around support B has to equal 0, but when you add all the up forces to all the down forces, you also have to get 0. And if you look, there are 4 total forces. F1 and F2 are both up. 3,000 newtons is going to go down. 4,000 newtons is also going to go down. So we can look real quick at F down plus F up. We know that our up forces are F1 plus F2. And then our down forces, which would be negative values, is 4,000 from here and 3,000 from here, and that has to equal 0. Another way to write that is just simply F1 plus F2 equals 7,000. That's our first equation. And that makes sense because it says the bar is massless. So we have 4,000 newtons down, 3,000 newtons down, total down is 7,000. That means that the total up, which F1 and F2 combined to do, has to be also 7,000 newtons. So keep that equation. I'm just going to erase it, but we will come back to it in a little bit. Second part for balance is torque. And as was mentioned in class, when you're looking at the torque, you think of the torque around pivot point A as if pivot point B weren't there. And that's exactly what we're going to do. It's the same thing. So pivot point A, it's a little bit more tricky because this 4,000 newtons is going to try to make it rotate counterclockwise. The 3,000 newtons, since it's down on that side, is going to try to make it rotate clockwise. And then you also have to include F2. That's a force acting at a distance away from A. So that's going to try to make it rotate also counterclockwise. So we got to look at those numbers, and we have a nice scale on top to help us identify those things. So the torque around pivot point A is comprised of a clockwise total torque and a counterclockwise total torque. And separately, they won't necessarily add to 0. In fact, they shouldn't add to 0. So our clockwise torques, as we said, we have 2 of them. And we're going to look at those. It doesn't matter the direction. We know that clockwise torques are negative, so it doesn't matter if it's on the left side or the right side of pivot point A. Our lever arm from A to the 4,000, as shown, is 3 meters. So negative just meaning counterclockwise. So negative 3 times 4,000 plus, I'm skipping the 3,000 because that's clockwise, plus from pivot point A to all the way at the end, well, I'm going to do the 12 and 5, so it's 17. But it's, again, counterclockwise, so it's got to be minus 17 F2. All right? Hopefully you can follow those, and if not, the beautiful thing around this is you can pause and rewind. So again, counterclockwise, I had the 2 torques, the 4,000 and the F2, all trying to make it rotate counterclockwise. That has to carry negative numbers to distinguish between, in the equation, clockwise and counterclockwise. We still got to add our clockwise torque. And that is from pivot point A out to there is 12 meters. So our lever arm is 12 times 3,000. And our torque around A is essentially solid, but it would be worth simplifying this a little bit. So torque around A is negative 12,000. Negative 12,000 minus 17 F2 plus, if I do 12,000 or 12 times 3,000, change to green, this one and this one, since they have no F2, can just be added together. What we get is torque around A is 24,000, that's the two greens added together, switch back to black, minus 17 F2. So we kind of get kind of a relatively simple equation. I'm just going to rewrite that right up here. So 24,000 minus 17 F2. So the torque around A is 24,000 minus 17 F2. Now we want to do the very same thing for torque B. This one's a little easier because there's no left side or right side. The 3,000 is going to try to make it rotate counterclockwise. The F1 is going to try to make it rotate clockwise. The 4,000, remember we're thinking as if A is not there, 4,000 wants to make it rotate also counterclockwise. So once again we have two counterclockwise torques. So torque B is torque counterclockwise plus torque clockwise, where torque counterclockwise once again has to be negative values. So I'm going to do the 4,000 first. From B, 4,000 newtons acts all the way across, so that's 20 meters, negative 20, negative 20 times 4,000. There's a second counterclockwise. I'm doing counterclockwise first. Acting away from point B is 5-meter lever arm, so I'm subtracting because it's counterclockwise. Minus 5 times 3,000, and again with balance, all of our angles we are assuming are 90 degrees. So that's my counterclockwise. Plus clockwise is F1 trying to do that. So F1 is acting 17 meters away from pivot point B, and it's 17 F1. We're going to leave that as a variable. So simplifying the counterclockwise, negative 20 times 4,000 minus 5 times 3,000. We get negative 95,000. So my torque around B, just simplified, is negative 95,000 plus 17 F1. Sorry, 17 F1. Remember, originally we said that torque A, for this to all balance, torque A plus torque B has to completely cancel to 0. So we're going to do a little simplification. We got to add torque A and torque B. 24,000 minus 17 F2 plus, that's torque A, plus negative 95,000 plus 17 F1. And I'll apologize for that. So, that equals my total torque. That's just torque total. And what I get has to equal 0, torque A plus torque B. And just a little simplification, 24,000 minus 95,000 gives me negative 71,000. So just over here. I get negative 71,000. I'm just simplifying a little bit. Negative 71,000 minus 17 F2 plus 17 F1 equals 0. That's a little messy. I want to simplify that a little bit. So add 71,000 to both sides. I'm going to get negative 17, just doing this in 2 steps. Negative 17 F2 plus 17 F1 equals 71,000. Just added 71,000 to both sides. Next step I'm going to do simultaneously, factor out a negative 17 and divide. Sorry, I'm going to factor out a positive 17 and then divide. So I'm going to get negative F2 plus F1 equals 71,000 over 17, kind of a weird number, is 4176.47. And I'm just going to rewrite this because I can. F1 minus F2 equals 4176.47. And I apologize if that's going over my face. So I get this relatively simple equation of F1 minus F2 equals 4,176. I'm like, all right, well, I have F1, I have F2, but I don't know either. So we go back to that original F1 plus F2 that we had. So let me clear these out. I had two equations. I had from forces that F1 plus F2 has to equal, we said, 7,000. The cat's making a cameo. I also just got that F1 minus F2 equals 4176.47. So I get this nice system of equations that I can solve, which will allow me to find F1 and F2. So the first one comes from the forces, the second one comes from the torques, even though it just looks like it's forces. But we use torque to find this second equation, which will let us solve. A couple different ways to do this. What I like to do is, since I have F2, one is positive, one is negative, if I just add both equations, literally and truly adding both equations, what I get is that F1 plus F2, so F1 plus F1, adding straight down, is 2F1. F2 plus negative F2 is 0, so that doesn't matter. And 7,000 plus 4,176.47 is 13,176.47. And then solving for F1 is 5,588. 5588.24 newtons. So I get F1 has to be 5,588 newtons. And since they have to add up to 7,000, I know that this one has to be 7,000 minus 5588. I dropped the decimals. I'll put them back in. 5588.24. So 7,000 minus 5,588.24 gives us an F2 of 1411.76 newtons. So we can check if we add 1411 plus newtons, 5588, you get 7,000. If you were to subtract this from this, you would get 4176. So we solved. We figured out how much A has to push up, how much B has to push up, and it makes sense that A pushes up more because there's this big 4,000 Newton that's really close to it on the other side of B. So A has to carry more. It's just there's more mass near it, so it has to push up harder than B does. And we'll demonstrate this in class. We have demonstrated this in class by the time you're watching this video. So you are responsible for this type of problem. Your numbers are a little slightly different, but the problem looks and works exactly the same way. Just make sure you're using your numbers, not mine. Make sure you really understand this, because tomorrow in class you're going to be teaching how to do this problem to a group of your classmates. So they're going to be teaching you their problem, so they're responsible for that, but you're responsible for this type of problem, to being able to lead them through this type of equilibrium problem. Great job, and I will see you tomorrow.